14.29, the decomposition reaction of N2O5 in carbon tetrachloride is, and then it shows the reaction right here, and it says the rate law is first order in N2O5. And it says the rate constant is equal to, and it gives us a numerical value per second. Then it says write the rate law for the reaction. So the rate law always starts rate is equal to K, and then it would be N2O5, and remember it's first order it says, so there would be a 1 right here. You don't have to write the 1 because it's just assumed that it's there. Letter B, it says what is the rate of the reaction when N2O5 is equal to. So now we take this concentration and put it in here, and so we'd be solving the equation rate is equal to K, which is 4.82 times 10 to the negative third per second, times the concentration they give us, which is 0.0240 molarity. So our units will end up being molarity per second, which is what rate would equal. And so when you multiply those two together, you get a rate of 1.16 times 10 to the negative fourth molarity per second. And then letter C, it says what happens to the rate when the concentration of N2O5 is doubled. So now we're going to take this concentration and double it to be 0.0480. So we'll replace that, and then you have to do this new math on your calculator, and you end up with 2.31 times 10 to the negative fourth molarity per second. And then in letter D, it says what happens to the rate when the concentration of N2O5 is halved. So now this becomes 0.012, and as we saw, it doubled right here. What would we expect if it went in half? Well, then we'd put this concentration in instead, and we'd end up with 0.578 times 10 to the negative fourth, or 5.78 times 10 to the negative fifth, which would be half of this as well. This is 29.